Greetings. I'm Mr. French. This is topic 3.6, calculating higher order derivatives. We're going to go over some examples for the AP Calculus AP Classroom curriculum. And I'm coming to you from my classroom in Mount Pleasant, Utah. Let's look at our first example. Let f be the function defined below. F of x equals 4 over x squared plus x to the fifth. What is the instantaneous rate of change of f prime at x equals 1? Okay, well, asking for the instantaneous rate of change is just a different way of asking for the derivative because they're synonyms. So they're not asking me for the derivative of f, though. They're asking me for the derivative of f prime, which means that I need to first find f prime and then find the derivative of f prime, or the second derivative of f. So let's start with f prime of x. Well, 4 over x squared can be rewritten as 4x to the negative 2 plus x to the fifth. And then I can take that derivative by the power rule. So bring down the negative 2. So negative 8x to the negative 3, negative 2 minus 1, plus 5x to the fourth, again by the power rule. Now I need to find the derivative of f prime, because that's what the question is asking, the instantaneous rate of f prime. So f double prime of x is, again by the power rule, negative 3 times negative 8, which is 24 positive, x to the negative 4, plus 4 times 5, again the power rule, x to the third, 4 minus 1. And there is our instantaneous rate of change of f prime, or f double prime. But now we need to find it at 1, so we plug in 1. 1 to the negative fourth is just 1, and 20 times 1 cubed is also just 1 times plus 20 there, so 44 is our final answer. Let's look at the next example. Y is the natural log of x squared plus 1. And then I need to find the answer to this expression. Well, this expression is asking me for the second derivative. I can't get to the second derivative without going through the first derivative. So first, let's find the first derivative, dy dx. Well, the derivative of the natural log of something is 1 over the something. This is a chain rule situation because it's not just x, times the derivative of the something. So the derivative of x squared plus 1 is just 2x because the derivative of 1 is 0. So let's rewrite this as 2x over x squared plus 1 and find the derivative. Here I've got a fraction, so my second derivative is going to require an application of the quotient rule. Using our rhyme, low x squared plus 1 d high times 2, derivative of 2x, minus high d low, so 2x times the derivative of x squared plus 1, which is also 2x, over the square of what's down below. And for a free response question, we could stop right here. If I wanted to simplify, I could distribute and get 2x squared plus 2 minus 4x squared over x squared plus 1 squared, which simplifies to negative 2x squared plus 2 over x squared plus 1 squared. And that would be a possible multiple choice answer. So 2 minus 2x squared over x squared plus 1 squared. Let's look at a final example for now. What does this mean? F33 of x. They're asking me, I'm asking you for the 33rd derivative of the sine of x? Mr. French, how can you be so cruel? maybe I'm not being quite as cruel as you think. Let's start by taking the first derivative and see what happens. So f prime, my first derivative of sine is cosine of x. And then our second derivative, well, the derivative of the cosine of x, we know is the negative sine of x. And then my third derivative would be the derivative of the negative sine of x. Well, the negative would carry through, and then the derivative of sine is just cosine of x. Now, what's my fourth derivative? Well, the fourth derivative would be the derivative of cosine of x, which is negative sine x, times the negative 1. Well, that puts me at sine x again. But that's what I started with. What's going to happen as I continue to take derivatives? Well, I'm going to repeat this cycle where I come back to sine x after every 4 derivatives. So, if I think about that, where am I in this cycle after the 33rd derivative? If I divide 33 by 4, I can see that 4 goes into 33 8 times, leaving me with a remainder of 1. So I will be 1 derivative into the cycle after 33 derivatives. Well, my first derivative of the cycle is just cosine x. So using this pattern of derivatives, I am able to figure out higher order derivatives of any magnitude for sine. Something to think about. Look for patterns in your derivatives, especially if they're asking you for large numbers of derivatives. And that's the end of our topic and the end of this unit.